Comencem. Hola, bon dia a tothom. Anem a començar aquest acte acadèmic, que és la defensa de la tesis de Marc Castaño. La tesis porta per títol Pharmaceuticals in Water Reclamation, Prioritisation and Monitoring for Sustainable Irrigation Practices in Mediterranean Regions. El tribunal està composat per la doctora Meritxell Gros, d'aquí de l'ICRA, que actua com a secretària, la doctora Mònica Brienza, de la Universitat de Basilicata, que actua com a vocal, i jo, Antoni Ginebreda, del CSIC, de l'IDEA CSIC, que tinc el dubtós privilegi de ser president. Dic dubtós perquè soc el més gran, simplement. El doctorant té uns 50 minuts o així, tindràs prou per fer la... Llavors nosaltres ens col·locarem aquí per escoltar, per veure la presentació i després passarem al torn de qüestions.
So, many thanks everyone for attending this defense, not only those who came presentially, but those who follow us also virtually. I'm going to explain the structure of the following presentation. First, I'm going to introduce the topic, explain the objectives of the present thesis, and then I'll jump to the results, each one being a chapter and therefore publication in a scientific journal. So, the climate change, together with overpopulation, anthropogenic activities related to agriculture, industrial, or urban sectors, have increased the pollution and have impacted the freshwater not only in quantity but also in quality. As a result, 2 billion of inhabitants suffer from water stress. Therefore, innovative water management strategies are required. Among them, the most promising one is the use of reclaimed water that is already being used in some places, but it's predicted to be used further in others. So among their uses, several different usages can be encompassed for reclaimed water. For instance, the irrigation of green areas, landscapes, and forests, the industrial applications, discharge to maintain aquatic bodies and minimum ecological flows, aquifer recharge, toilet flushing, but in Spain, its major usage can be found in the agriculture sector as irrigation water. Actually, up to 40% of the reclaimed water serve this purpose. This practice offers many benefits, as contributing to soil fertility, providing essential micro and macronutrients, reducing the reliance on synthetic fertilizers, and lowering production costs. However, it also has some drawbacks to be considered. As for instance, the influent wastewater contains several pathogens and pollutants. Therefore, in order to ensure safe reuse of this reclaimed water, it's relevant to effectively remove them, remove these pathogens, these bacteria, these pollutants. And therefore, legislations are also required. Back in 2020, the European Union issued a legislation on water reuse. This legislation was effective in 2023. It's focused in irrigation in agriculture, and depending on the crop and the irrigation method, the legislation sets different water quality standards and determines the required treatment each water quality requires. Additionally, it determines an amount of parameters to be monitored together with an acceptance criteria for each one. At the national level, Spain issued a royal decree in 2024. This legislation considers more usages of reclaimed water, such as urban, industrial, environmental, and other uses. And while it also considers irrigation, it considers irrigations beyond agriculture. Additionally, it also considers agriculture. But for instance, it considers irrigation to green areas of cities. It sets more detail into the classification of water qualities and considers the way the crop is processed before consuming it. If it is raw, if it's boiled, sets different criteria. It considers additional water treatments and one more parameter to be monitored. However, none of these legislations consider the organic micropollutants. The organic micropollutants are substances that, even at low concentrations, might have an impact into the ecosystems. Several compounds and several classes can be encompassed among them. For instance, pesticides, plastic additives, flame retardants, PFAS, personal care products, metals, and lastly, pharmaceutically active compounds. These compounds are specially designed to interact with the biological receptors of animals, microorganisms, or humans. Therefore, it's essential to consider them in the framework of water reuse. So, last year, in 2024, the European Union issued a first legislation on wastewater treatment. This legislation considered 13 compounds and classified them in Category 1 and Category 2. Most of them are pharmaceutical active compounds. In order to comply with these criteria, wastewater treatment plants should achieve at least an average removal of at least 80%, but for at least 6 compounds. These 6 compounds had to comply a ratio for Category 1 and 2 from Category 2. In parallel, the European Union issued the watch list. These watch lists are a list of compounds to be monitored over the next 2 years. So from 2015 to 2025, a total of 5 watch lists were issued. These watch lists covered up to 71 compounds, 18 of them being pharmaceutically active compounds. In this last watch list of 2025, up to 27 compounds were considered, 8 of them being pharmaceutically active compounds. Therefore, it's essential to find strategies and technologies able to mitigate the concentration of these compounds in the influent wastewater. Among them, the conventional activated sludge is the mostly used everywhere, since it's flexible and it effectively removes the organic matter. It consists in activated sludge, it's mostly anaerobic, and the removing mechanism is the microbial degradation or the suction to flux. Nonetheless, it's not the only treatment that is available, and alternative treatments can be found in literature. For instance, deconstructed wetlands. Deconstructed wetlands consist in a vegetated area and have aerobic and anaerobic zones depending on the point of the wetlands and the orientation of the wetlands. The mechanism is the microbial degradation, the sorption, but also the plant uptake and the photodegradation. And another alternative treatment that can be found in literature is the USB, the upflow anaerobic sludge blanket. As its name indicates, it's an aerobic treatment that consists in a granular sludge. Therefore, the removing mechanism is the microbial degradation. It's important to consider the advantages and disadvantages that every treatment has to offer. For instance, the conventional activated sludge, as I just said, has a high and a stable organic removal, it's widely implemented, and has a flexible operation. Nonetheless, it presents high cost, not only of operation, but also of maintenance. On the other hand, the conventional activated sludge offers a variable removal depending on the climate, since in warmer climates, higher removals are expected, and it also depends on the hours of light exposure. It has a lower startup and requires a large area. Nonetheless, it has low energy requirements, low energy needs, and is integrated into the landscape. In the case of USB, it has a lower removal and requires a selected temperature between 20 to 4 degrees to reach its peak performance. However, it has lower energy consumption and produces biogas and has a small footprint. Nonetheless, none of these treatments is able to effectively remove totally the concentration of all the pollutants. Therefore, some strategies are required in order to assess those risks related to their concentrations to the ecosystems. The first ecosystem in risk is the ecosystems in surface water upon effluent wastewater discharge. In this case, the risk is assessed by the calculation of a risk quotient. And this risk quotient consists in the ratio between a predicted or a measured concentration to a predicted no effect concentration, the concentration of a substance where no effect is expected and no risk is spotted. So this PNEC, this predicted no effect concentration, is obtained from the ratio of a toxicity threshold, that several different thresholds can be considered in literature, together with an assessment factor. In case the risk quotient is above 1, the substance is considered of risk for the ecosystem. In the framework of reclaimed water reuse for irrigation, the other ecosystem that can be endangered is the ecosystems living in the arable soils. Similarly, as in the last case, it is assessed by the calculation of a risk quotient, and as in the last case, risk quotients above 1 represent the substances that might have or might provide risk to the ecosystems. In this case, it can be also measured or predicted, the concentration. In this thesis, the concentrations in soil have always been predicted, and they have been predicted using the following formula, where V is the volume of water for irrigation, C is the compound concentration in reclaimed water, D is the number of days for harvesting the crops, caps D, the depth of the soil, and rho, the soil density. In the case of PNEC, it is obtained from the PNEC in water together with the carbon-water partition coefficient and the fraction of organic carbon in the soil. Lastly, in case of ingestion of the crops irrigated with reclaimed water, a risk assessment for human health must also be performed. In this case, the assessment is performed by the calculation of a hazard quotient. This hazard quotient considers the ratio between the ADI and the ADI. In this case, the EDI is the estimated daily intake. The estimated daily intake is the amount of crop that it is assumed for an individual to daily consume. And in the case of ADI, it's the maximum acceptable daily intake. It's the amount of a substance, in this case pharmaceutical, that can be ingested without having any effect. Therefore, the ADI is obtained from the lowest daily therapeutical dose, together with an assessment factor and the weight of the consumer. As in the other cases, in case the hazard quotient is above 1, the substance is considered as a risk for the consumers of the crops. So, given the enormous number of pharmaceuticals, it's impossible to consider them while legislating, while developing analytical methodology, or for most purposes. Therefore, it's important to set criteria to determine which pharmaceuticals are of relevance for each purpose. These strategies are called prioritizations. The first way of prioritizing that can be found in literature, for instance, is the occurrence-based prioritization. In this case, the selection only considers the concentrations of these compounds and is the only thing that determines if the compound is prioritized or not. It is useful for evaluating the treatment performance and calculating pharmaceutical loads. Then, the risk-based prioritization integrates toxicity data together with the occurrence data. Therefore, in this case, the prioritization is performed using the risk quotients. The compounds having the highest environmental risk are prioritized. Lastly, the OPBT prioritization combines occurrence and toxicity data but additionally persistence and bioaccumulation. In these prioritization systems, a score is assigned for every pharmaceutical in each considered field, and then these scores are added. Compounds surpassing a detailed threshold are prioritized. So, in this framework, the objective of the present thesis was to collect the occurrence data of pharmaceuticals in multiple Mediterranean water matrices as influent, effluent, rivers, or sea, then develop analytical methodology to enable this analysis, monitor the selected pharmaceuticals in 2 different Mediterranean areas, evaluate the pharmaceutical remover in 2 different removing mechanisms, different treatments, the first being a conventional activated sludge, the second being a USB plus constructed wetlands, and then perform a risk-based prioritization of pharmaceuticals in Catalonia, evaluate their risk in both soil and aquatic ecosystems. Lastly, assess the risk to human consumers associated with the use of reclaimed water for crop irrigation in Catalonia. These activities were grouped as follows. So, in Catalonia, the in-house database was built, the method was developed, a conventional activated sludge system was monitored, a risk assessment was performed in both aquatic and soil ecosystems, and a prioritization in a water reuse scenario was performed. In Greece, the USB plus constructed wetland system was monitored, and the risk assessment was performed in both aquatic and soil organisms. Chapter 1 covers the in-house database, the method development, the monitoring system in conventional activated sludge, and the risk assessment in soil and aquatic ecosystems. Chapter 2, the prioritization under a water reuse scenario, and Chapter 3, all the data coming from Greece. So, going to the results. The first publication, entitled A Decade of Water Monitoring in a Mediterranean Region, Pharmaceutical Prioritization for an Upgraded Analytical Methodology, was published in Environmental Nanotechnology Monitoring and Management back in 2023. In this publication, the purpose was to build the in-house database, select the most ubiquitous pharmaceuticals having higher occurrences, develop the analytical method, and perform a sampling campaign in 2 different Mediterranean areas with this developed method, in Catalonia, in Greece. However, in this chapter, I'm only going to talk only about the monitoring in Catalonia. As the monitoring in Greece, I will explain it further. So, going to the prioritization, it consisted an occurrence-driven prioritization using the last 10 years of monitoring campaigns performed by the ICRA institution. Therefore, it covered 2011 to 2021. Several water matrices were considered as hospital wastewater, influent wastewater, effluent wastewater, and river water. Up to 29 publications were considered, encompassing 158 pharmaceutical active compounds. A score was assigned for every pharmaceutical in all considered matrices, and then, upon combining these scores, the final score was obtained. The compounds having the highest score were prioritized. The final list covered the 50 compounds having the highest scores in occurrence. Upon gathering all these concentrations during all these years through these monitoring campaigns, some conclusions could be extracted. First is detailed in this graph. Well, it encompasses the concentration of the therapeutical classes in the different considered water matrices, is that the total concentration of pharmaceuticals decreases over the graph. This means that the concentrations in hospital wastewater were higher than those in influent wastewater, that were higher than those in effluent, than in the river, and lastly than in the sea. It is also relevant that the highest concentration in this graph is achieved for a therapeutical class of X-ray contrast agent, though it only has 1 compound, which is iopramide. Lastly, it's also relevant to notice that in the influent wastewater, the highest concentration is for analgesics and anti-inflammatories. It is even 1 order of magnitude higher than any other therapeutical class in this matrix. Going to the individual compounds, the 25 compounds having the highest scores of occurrence are plotted in this graph with the concentrations in all the considered matrices. It's interesting to notice that almost half of them are metabolites or transformation products, which are substances that are not always considered. In some cases even, as is the case of ibuprofen metabolites, the concentration of these compounds is even higher than the one of the parent compound. Upon selecting these compounds, the method was developed. The method consisted in an adaptation from Gross et al. 2012 and Gross et al. 2013. Briefly, it consisted in a sample filtration and a solid phase extraction using HLB cartridges. Depending on the water matrix, different cartridges, different sizes of cartridges were used. Then the samples were injected into the UHPLC Q-trap system. Once the method was developed, a monitoring campaign was performed in Catalonia and Greece. But as I said before, I'm going to only talk about the results in Catalonia in this chapter. So wastewater samples consisted in influent wastewater and effluent wastewater from the wastewater treatment plant in Girona and were composite samples for the last 24 hours. In the case of river, there were grab samples taken before and after the wastewater treatment plant. And in the case of sea, obviously they were taken from the Mediterranean Sea near the mouth of the river, and there were also grab samples. So going to the results, the highest concentrations were obtained for acetaminophen and carboxyibuprofen, these two compounds. However, these substances are known to be effectively removed by conventional activated sludge system, as the one we have in Girona, and therefore the removal was as high as 99% for acetaminophen and 99.8% for carboxyibuprofen. Therefore, they are not anymore the substances having the highest concentrations. Nonetheless, the 5th compound at the highest concentration, which is hydrochlorothiazide, is hard to be removed by conventional activated sludge system, and therefore it became the compound at the highest concentration in the effluent. Upon gathering these concentrations in the effluent, it was possible to assess the environmental risk that these substances at these concentrations pose to the environment. The following graph details these risks. The blue bars detail each compound concentration in the effluent of the wastewater. The pink dots, the risk quotient in surface water. The green triangles, the risk quotient in soil. And lastly, the red line determines the threshold to determine that one substance has a risk for the considered ecosystem. The substance at the highest concentration, which is hydrochlorothiazide, did not have any risk for none of the ecosystems. In contrast, up to 6 compounds presented a risk in at least one of the matrices. In surface water, up to 4 compounds presented a risk, highest risk spotted for ibuprofen. In the case of soil, 5 compounds presented a risk, highest risk spotted for iopramide. Next, in chapter 2, which is selection of pharmaceuticals of concern in reclaimed water for crop irrigation in the Mediterranean area, it was published in Journal of Hazardous Materials back in 2024. In this publication, a prioritization in a water reuse context was performed. Going to the methodology, the first step consisted in OPBT prioritization using the data from the in-house database, but updated with one additional paper. And then the prioritization was performed. Selected compounds were considered to perform an environmental risk assessment on soil. Additionally, a prediction of crop uptake was performed on the prioritized compounds. In order to be predicted to be taken up, these compounds had to have molecular weights lower than 1,000 grams per mole, pKa upper than 7, and log D between 1 and 4. This prediction does not provide exact concentrations, and therefore it's not possible to perform a human health risk assessment on the crops irrigated with this reclaimed water. Therefore, in parallel, a literature review was performed, and the human health risk assessment could be assessed for adults and toddlers. The considered crops in this assessment were tomato and lettuce. So the OPBT criteria was the following one. The occurrence was obtained from the in-house database. The persistence was also calculated from the in-house database, considering only studies that sampled both influent and effluent wastewater. In the case of bioaccumulation, it was calculated using the EcoSAR software. In the case of toxicity, it was obtained from the normal database, if possible, and if it's not reported, the EcoSAR software was used. In case the compound had no available data, nor it could be calculated, a score of 3 was assigned. The compounds that had a score of 12 or more were prioritized. After applying these criteria, up to 47 compounds were prioritized. The highest score was obtained for diclofenac, which reached almost the maximum possible score, up to 19 of 20 points. Among them, it's also important to notice that 14 compounds were psychiatric drugs. While these compounds might not have highest occurrences, their persistence, toxicity, and bioaccumulations make them of relevance in this kind of prioritization. Upon prioritizing these compounds, an environmental risk assessment on soil could be performed. It was performed as detailed into the introduction, and all the parameters were extracted from literature, with the exception of the carbon-water partition that was calculated using Cochrane. From the results, it emerged that up to 6 compounds were determined of risk, half of them being antibiotics. In this graph, only lettuce is reported, but the tomato was also considered. Lettuce is the only one that is reported in this graph because it's a worst-case scenario. As in the graph, the volume required of water is considered, and lettuce requires way more water than tomato. Even requiring less days to be harvested becomes the worst-case scenario. So the human risk assessment was also performed, calculating the amount of crop that can be safely ingested. The AGI was extracted from literature, and the measured concentrations were obtained for literature. It's important to notice that the weight of the consumer was also extracted from literature. Lower weights have higher risks, and therefore low weights were considered. Going to the results, it emerged that the threshold was set for the concentration of diclofenac together with this AGI. In order to have the first effect, a toddler had to ingest 650 grams of lettuce or 1.5 kilograms of tomato daily. These amounts are considered unrealistic, and therefore no risk is spotted. Going to the third publication, which is the evaluation of pharmaceuticals removal through a full-scale USB system in a water-scarce Mediterranean region, the USB plus constructed wetland system was monitored. Up to 2 sampling campaigns were performed, the first one in fall of 2021, the second in summer of 2022, both obviously in Greece. Sampled points were the following one: the influence of the wastewater, the effluent of the USB, and lastly, the effluent of the constructed wetlands. Considering the results of this monitoring together with those obtained in the chapter 1 in Greece, the following graph is obtained. It is observed that the highest concentration is always achieved for the compound acetaminophen, that the concentrations in summer are always higher than those in fall. If we consider only these sampling campaigns in summer, and therefore the only variable is the year, a decrease in naproxen is observed, while an increase of naproxen is also observed. In the same line, the beta blockers in 2022 were much higher than in 2019. The contrary effect is observed for diuretics and antihypertensives. This can be due to changes in prescription practice, but it can also be for disease incidence. Going to the removal of only USB, the following graph is obtained for the two different considered compounds. It emerged that a 46% of removal was obtained in summer and a 42% was obtained in fall. However, these removals are mainly due to the effective removal of only one compound, acetaminophen. If acetaminophen is not considered, in summer the removal is 0%, and in fall it's even negative. Negative removal means an increase of concentration after the treatment. These negative removals are detailed in literature as cleavage of the conjugate and or retransformation of metabolites back to the parent compound. Nonetheless, the USB was not the only mechanism treating this wastewater, as it was coupled to an hybrid constructed wetland system. The removal achieved by these constructed wetlands plus USB tandem is detailed in this graph. Removals range for 64 to 69% depending on the season, overall removals, and only 15 pharmaceuticals had concentrations greater than 1,000 nanograms per liter. It emerged that some compounds were effectively removed, as acetaminophen, as ibuprofen or atenolol, but some were challenging to mitigate, as it were 2-OH, ibuprofen, sotalol, furosemide, hydrochlorothiazide, or diclofenac. Upon comparing the obtained removals using this technology with the obtained removals with the conventional activated sludge system, the following graph is obtained. In this graph, the compounds that had the highest scores of OPVT, together with the ones considered in the wastewater treatment legislation, are plotted. And it is interesting to notice that for almost all of them, the conventional activated sludge system offers better results. However, some exceptions can be found, as for instance, venlafaxine. It's relevant to say that none of these technologies would meet the requirements set by the legislation. The compounds in green are the ones that are considered in the wastewater legislation. As I remember, at least an 80% of total removal must be achieved, considering 4 category 1 compounds, 2 from category 2. Both technologies would fail as only one for each of them surpassed the threshold of 80%. After gathering the concentrations in the effluent wastewater for Greece, the risk assessment was also assessed. As in Chapter 1, same kind of graphic is reported here. As a reminder, blue bars determine the concentrations, pink dots the surface water risk quotient, green triangles the risk quotients in soil, and the red line the threshold for being considered as risky. Additionally, one more time, the compound at highest concentration, in this case, valsartan, did not present any risk for none of the considered ecosystems. In contrast, up to 9 substances were predicted to have an impact in at least one of the considered ecosystems. In surface water, up to 8 compounds were predicted to have a risk, highest risk obtained for ibuprofen. In the case of soil, only 4, and the highest risk was predicted for MTPA. Lastly, in this thesis, the concentrations in soil had always been predicted using this formula. Therefore, in order to assess the functioning of this model, a literature review was conducted, gathering concentrations on effluent wastewater, but also concentrations in arable soils. Using the concentrations on effluent wastewater, the concentrations on soil were predicted and were compared with the real concentrations measured. It emerged that generally the predicted concentrations were lower than those measured. And one possible reason is that the current model does not consider the compound properties. It only considers the compound concentrations and the soil characteristics. The formula considers the volume of water for irrigation, the compound concentration in water, the number of days for harvesting the crop, the depth, and the soil density. but there's no consideration of, for instance, the octanol water coefficient. So in order to summarize the findings of the present thesis, the compounds having a risk in at least one of the ecosystems on at least one of the areas are listed in this table. Up to 11 compounds represent a risk for at least one matrix or area. In the case of water, only metoprolol acid, MTPA, would not have any effect. And up to 2 compounds, ibuprofen and O-desmethylvenlafaxine, would be especially relevant as they are of risk in both areas. In the case of soil, less compounds would be considered of risk, at least 6, but up to 3 are risky in both areas. Ibuprofen, another time, furosemide, and MTPA. If we consider only the area and not the matrix, in Spain, ibuprofen, clarithromycin, and iopramide would be of risk for both ecosystems, surface water and soil. In the case of Greece, it would happen for ibuprofen one more time and furosemide. Lastly, upon comparing these compounds that are predicted to have an impact with the OPVT selection performed with data from Catalonia, it emerged that every compound that is predicted to have an effect in Spain was prioritized by means of OPVT, determining the correct functioning of this predicting model assessing environmental relevances. Nonetheless, up to 3 substances, that are 2-OH, ibuprofen, naproxen, and tetracycline, were not selected by means of OPVT, but in Greece, not in Spain, in Greece, a risk is predicted. This determines that it's important to perform an OPVT prioritization in the area of the study. So if the tribunal agrees, I'll proceed to read the conclusions. So up to 50 pharmaceuticals the 50 pharmaceuticals at highest concentrations were prioritized. Analgesics and anti-inflammatories were the most prevalent, up to 15. Ibuprofen, TPs, 2-OH, and carboxy had the highest concentrations in influent wastewater, even more than the parent compound. The highest concern in OPVT was for diclofenac, azithromycin, and O-desmethylvenlafaxine. The highest risk for organism in soil was set for iopramide, and no human health risk were foreseen. The analytical method covered 49 most relevant pharmaceuticals in Catalonia. It included environmentally concerning compounds, as well as 14 of the 18 pharmaceuticals from the last 5 watch list, and 6 of the 10 pharmaceuticals listed in the EU Wastewater Directive of 2024. The conventional activated sludge system performed better than the USB system, reaching removals from 97 for conventional sludge compared to the 64% achieved for the USB plus constructed wetland. Nonetheless, the USB removed venlafaxine much more efficiently, up to 90%, than the CAS system. However, as a drawback, the main metabolite, O-desmethylvenlafaxine, which is also environmentally relevant, increased the concentration through the treatment. Up to 10 pharmaceuticals could pose a risk to the aquatic ecosystems. Ibuprofen and O-desmethylvenlafaxine are especially relevant as they are of risk in both areas. In the case of soil, 5 compounds were of risk in Catalonia: ibuprofen, furosemide, MTPA, clarithromycin, and iopramide, and 4 in the Greek islands: ibuprofen, furosemide, MTPA, and tetracycline. In the assessment of the model predicted the concentrations in soils, it emerged that the measured concentrations are generally higher than the predicted concentration, as the concentrations are systematically underestimated. And lastly, the studied pharmaceuticals do not pose a risk to the consumers in case that reclaimed water is used to irrigate tomato and lettuce. Lastly, I would like to acknowledge all of my colleagues, as well as the received funding during these years. Many thanks for your attention. És que em cau, per això me'l fico bé. Vale.
Gràcies per la presentació i sobretot per haver estat amb el temps requerit. I ara és el moment de les preguntes. Now it's time for questions. Farem les preguntes sigui en català, en anglès o en castellà. O sigui,
Okay.
Cadascú te les farà. Començarà la doctora Meritxell Gros, com a secretària de...
Say, well, good morning, everyone. I think I will do it in English
Yeah,
because,
fine.
well, then Monica, you can also understand, okay? Well, first of all, I would like to congratulate you and your supervisors for all the work done. I really enjoyed reading the thesis. I think it's very concise and very clear. So and for me, it was also informative regarding first the new legislations and so on, so it was nice. And also think that you did a very good presentation, like you synthesized very well all your results, and it was very easy to follow, so I also congratulate you for this.
Thank you.
And well, I just have a few questions. And the first one is regarding your prioritization in chapter 1, no?
Yes.
To perform this prioritization, you start with a list, and this list is based on occurrence data, no?
Yes.
But would it be useful also to combine this occurrence data with prescription data in the countries? Because sometimes the compounds that are included in methods, we are based on information on other previous methods, but it doesn't maybe sometimes include all the compounds that are more consumed in a country, no? So, yeah, do you think that these prioritization strategies should also integrate the prescription data? And what are the challenges, no?
It's
associated with
interesting.
that?
I think it serves different purposes because it's true that some compounds are relevant because are very prescripted, but I'd like to bring the attention to the case of amoxicillin, for instance. Amoxicillin is the antibiotic that is one of the most highly prescripted and has a very low stability on water. Therefore, in my prioritization, it had a very low number, very score, and was not prioritized because the purpose of my analysis was to have a method able to calculate the highest concentration of pharmaceuticals in the effluent wastewater and compare them to the effluent in 2 different treatments. Therefore, in my work, it was better to focus only in the concentrations because of that, because some compounds, while they are very high prescripted, that have low excretion rates or low stabilities, and in the end I would not be able to measure them, and I would not be able to assess the removal into the wastewater treatment plant. Nonetheless, for other studies, I think it's a very good idea, yes.
Okay, thank you. And also, okay, I understand that you use this prioritization to upgrade an analytical methodology, no? That was already in place. I wanted to ask you what are maybe the advantages, no, of the new method that you presented. Also, you incorporate new transformation products. What was the criteria to select these transformation products into the methods? Or metabolites also, no? You have both.
The idea was to select those that were at highest concentrations. The previous method, it considered some of the metabolites, but after performing the prioritization occurrence based, we detected that in other methods that had several transformation products, detected high concentrations for some selected TPs, and we decided that it could be interesting to add them, since these compounds achieved high scores on the prioritization system. So the ones that were prioritized and the ones that the method was able to work, the method could work analyzing them, were selected and were grouped.
Okay. Was it challenging to find the standards for the transformation products? Or?
Well, not always challenging, because some of these methods, some of these transformation products were already analyzed, but in other methods. So the objective of the PRISM method was to have only one method to enable the analysis of all the pharmaceuticals that were ubiquitous. So before having this method, the data from the selected pharmaceuticals could also be obtained, but up to 3 analyses had to be performed.
Okay. Okay, thank you. Okay, also another question is related to the prioritization and risk assessment in soils.
Yes.
that to predict the risk in the soils, to derive the PNEC values in the soils, you use the values in PNEC water.
Yes.
No, but I wanted to ask you how precise is this approach, no? Because PNEC water is based on endpoints that may have different exposure pathways and sensitivity, no? Compared to soil organisms. Yeah, I wanted to ask you about that. How precise could be this approach?
That's
what are the
true.
limitations, no, of this approach?
That's true. Very few data is available of in vivo experiments in soil. We have found very few. I remember one of Isidia fetida that analyzed the effect of ibuprofen, and it was pretty much the same endpoint that we predicted using the formula. However, it's one case. Very much more studies would be required to effectively assess if the model is able to predict these concentrations.
Okay, okay. Then also in the second paper,
Yes.
which I really liked it, I think it's very nice.
Many thanks.
But okay, you apply first the first prioritization.
Yes.
No? And after that, you apply like different prioritizations, no, to assess the risk in the soil, the risk in
Yes.
crops, etc. Would it have been good maybe to combine all these prioritization, how do you say, endpoints or strategies to have one single prioritization? You know what I mean? To apply all
Yes.
the criteria, to have one single final list.
Yes, that's very interesting. This would be very concise. I like the idea, and would be really useful for studies that are able to know the compounds having higher relevance in terms of water reuse. The advantage of doing it separately is that I can see further the information given for every threshold. So I'm able to see that, for instance, one compound is environmentally relevant in terms of OPVT, but it's not of risk for the ecosystems in the surface water. If I do it all together, the only conclusion that I would extract is that the compound is not of risk for the surface water, which is, in the end, my objective. But following this way, I have a little more information. But I think it's very concise, and it's interesting to get to the results effectively.
Okay, thank you.
Thank you.
Also, from the prioritization in the soils,
Yes.
you highlight like 5-6 compounds.
Yes.
And I was surprised that as the top scored compounds, the top ranked compounds, you have penicillin G and then ceftiofor. And these compounds, they are hardly ever detected in soil because they are quite unstable. But then other compounds like ciprofloxacin, that they are also widely found in soils, they are not highlighted. So do you have any comment on that? No? Like maybe how, is it 100% reliable, no? The prioritization strategies? Okay, they are a guidance, of course, but how reliable are they, no? What do you, on your opinion?
Well, the thing is that what it's concerning is that upon calculating the risk, it emerged that the model did underestimate the predicted concentrations because it did not consider the compound properties. Nonetheless, in the case of PNEC, right, it will be long if I do it this way. It will be better at this. This one. In the case of PNEC, the carbon-water partition coefficient is considered. Okay. Therefore, I think that the risk model in soil has to be also assessed. It's important to perform in vivo experiments upon refining this model on predicted concentrations to determine the accuracy of the method. Right now, after performing this assessment on the predicted concentrations, I am not able to say if indeed penicillin G would have an effect on the ecosystems without having an assessment with in vivo data. Yes.
But also your PEC concentrations, they are estimated on a single irrigation, in a single application.
There are mean concentrations of several, well, in which paper, sorry?
No, when you estimate the predicted environmental concentrations in soil,
Yes.
with the formula that you use,
Yes.
you only consider one single cycle, so to say.
Yes.
No, but maybe in real scenarios, no,
Ah,
you are applying wastewater
loads.
continuously. Maybe there is a
So
build-up, no?
there'll be accumulation
Yeah.
over the
Do you
time.
think that this could have also an effect on the differences found?
The thing, that's an interesting point. The formula tries to apply that because in the end, it considers the volume of irrigation daily. So it considers the number of days of irrigation, so the total volume of water that reaches the soil. However, it's true that the concentration is only one measure, we could say, of a median of 3 measures, but one day. It could be very interesting to have an integrated system that could monitor these concentrations in water and have a model that would cover all the days from tomato or lettuce. Yes, that would be much better than the current model.
Okay, thank you. Also, in the part of the risk assessment for the human health risk assessment.
Yes.
Yes, in your paper, you estimate, if I understood it correctly, no, you estimate the amount of crop that should be consumed, no, to have a risk. But here in the presentation, you showed a different approach, no, that
Yes.
is to compare the estimated daily intake with the accepted daily intake. If you use this other approach, do you think that the results would have been a bit different or not? I mean, what is the most widely used approach? What is the best one to go for, in your opinion?
In my opinion, it's better to use the approach that I used in the paper because the problem, in my opinion, for the estimated daily intake is that it assumes an amount of crop to be consumed by individual, but different scenarios can be considered. It's not the same amount of crop can be considered in different areas, in different nutritions, and therefore it might be misleading because maybe in the estimated daily intake I consider a very low amount of lettuce and some individuals of a population consume much higher amounts. And when I said that no risk was spotted, they would indeed have risks. Therefore, I prefer to have a worst case scenario approach in which I provide the maximum amount that can be consumed. I think it's an easier way to spot the possible risks.
Okay, thank you. And also, in your thesis, no, you are mainly based on target methods.
Yes.
No, where you have pre-selected compounds and so on. But nowadays, we are almost, there is a shift, no, in using these wide scope screening techniques and so on. Do you think that it would be more appropriate to use these methods to have more information about what compounds we can find in the environment and then apply the prioritization strategy and so on? What do you think are the advantages or limitations of?
Definitely. That's something that could have improved my work. In this thesis, I think the best moment to use this would be in chapter 1, to gather all the possible metabolites or transformation products, and then perform target strategies to get their concentrations into the environment, so then I'm able to know if they have an impact or not into the ecosystems. But yes, definitely, non-targeted strategies or suspect screening strategies do offer information that can be combined with a targeted strategy.
Target, yeah, thank you. Well, I'm coming with my last question. I mean, you showed, no, that all the treatments that you assessed in your thesis didn't comply with the current wastewater directive, no, the regulations.
Yes.
And then maybe, what do you think, what improvements, no, would you recommend or you would think that are needed to achieve an effluent wastewater that is suitable, no, for wastewater reuse, for instance?
Considering only pharmaceuticals, different tertiary treatments can be performed as UV, for instance, or ozonation. In order to know which one works best, experiments would have to be performed, or literature review would have to be performed in order to gather the removal of these substances in these treatments. However, I'm sure that the implementation of a tertiary treatment has also some other things to consider, has some costs, and other parameters have to comply with the current legislations. So, considering only pharmaceuticals, I would perform a literature review to see which one does achieve a better removal of the compounds that are more difficult to mitigate.
To remove. Okay. Bueno, thank you very much, and
Many
congratulations again. Now I give the turn to Monica.
Okay. Thank you for your presentation, your nice work, and also congratulations your supervisor that with you achieve this work with the publication, etc. So you did a nice PowerPoint presentation. You managed it, in equal part, the introduction with the objective and the discussion, but I just observed some error on the numbers in some part. The decimal separation was a comma and not dot, so maybe you will rearrange it.
Thank you.
I'm sorry, but I checked the details.
Thank you.
But it's okay, it just happens, and nothing I'm here also for this, you know. So, but me more than, I have some curiosity, okay? I'm not really question, I'm not like make you under investigation, so it's just question. I did well understand in your slide number 23, we was speak about your analytical methods. So you was show SPA or SPA, 25 ml and etc. But between trap, there was like 3 ml or, you put it?
Yes.
6 ml. So this is what is a dilution effect of your sample? Is mean that you take 3 ml of the sea or water and you make your pre-concentration, or is what the final volume of your sample, the pre-concentration effect?
It's the volume of the SPA cartridge. So I used 3 milliliters cartridges for loading the wastewater and river samples, but for the sea samples, given the high volume, I required bigger ones that were 6 milliliter SPA cartridges.
Okay, so it means that after when you draw your data, you normalize all of them basing on the different volume that you have on your samples.
Yes.
Okay, fine. It was just curiosity. Another slide, the number 21. You didn't spend a lot of words on the effect, let's say, why you found all concentration less on the sea. For me, it was quite, theoretically can be logical, because of course the sea, you have high dilution, natural high dilution effect. But my question in this is always a little bit of curiosity. How you sampling in the sea? Your point was close the eventual outlet of wastewater plant, or was random, or was, or you were following maybe with other colleagues, I don't know, some kind of hydrological models, because to compare the sea to the wastewater treatment, you move from hospital, that of course is logical, should be more high concentration of pharmaceutical, because it's hospital. If you are there, you are using medicine, is quite logical, to the sea. So why you decide to compare this free matrix? Because the river, I can understand, surface water, he has not the same quantity of the sea, let's say, but why you decide to use these 4 different water matrix in your in this experiment or in your study? Or maybe you can use them but compare in different way, I don't know, in different contexts, or maybe the C1 you just maybe be focusing in maybe seasonal data, because for sure they will be different from summer, spring, and winter. I don't know. It is what,
Yes.
what do you think from your experience, data collection, and etc.?
Well, in the end, the sea data was not considered for the prioritization because the concentrations were very low and very few studies sampled it. So we only took into consideration the hospital, the influent, the effluent, and the river. But the objective of the thesis, in this prioritization was to determine the highest amount of pharmaceuticals, but also the most ubiquitous over-the-water matrices, to having analytical method that could work for all the considered matrices. So in case the analysis performed in hospital wastewater or in river water, the method would be able to detect high concentration of compounds that are normally detected. It is true that it would be better to tailor the method depending on the purpose of the analysis and perform different prioritization strategies. So therefore, if the ONLIT is going to be only used for the river samples, then consider only river monitoring campaigns. That would be very interesting, but would then in 4 different methods. And our objective was to have only one method that could work for the influent wastewater, for the effluent wastewater, but also for river.
Okay. Since in the conclusion part, your slide 25, so you highlight the efficiency of conventional activated sludge on removal, right?
This one, I think.
No, maybe I 25 it was maybe. No, this is 26, no?
25.
No. Maybe it was the one of the last. But it was one slide that you highlight the sludge, activated sludge. Was
okay.
better than maybe I wrote wrong on my paper.
Might be this?
Yes.
Okay.
Okay. So, did you take in account also from literature that a lot of compound that maybe you are declared in some way potential removal are just accumulating the sludge? So in the end, maybe you have only, for you is removal because of course you don't found in your water, but in the end they can just be on transfer of the status of the molecules, mean that from the liquid is just accumulated in the sludge. The disease is one of the main problem, let's say, of activated sludge, when the sludge, for example, we would like to use as manure in agriculture because they can accumulate some of contaminants. If you, maybe just for, also this is kind of curiosity, if you check or if you read or you will do it to make double check if what you found or you say that are removal, some of them for their characteristic properties, maybe they can just be accumulated. So it means that they're still there.
That's true. Yeah, definitely that's one of the problems with conventional activated sludge. I have not considered this in the present thesis because the focus was on the quality of the effluent water. But it's true that it is a drawback that has to be considered upon using conventional activated sludge systems, since the concentration is still there. It is not eliminated and might have the effect that the removals are better than they actually are. Yes.
Okay, great. Like it. So another curiosity. In your criteria, you select the bioaccumulation effect. Why? And why bioaccumulation and not another parameter? For example, I don't know, did you check if in your list you also take in account which are the possibility effect of these contaminants on aquatic environment, since we are working on water matrix?
In the OPVT prioritization?
Yeah, like the bioaccumulation, you selected
Yes.
bioaccumulation, right?
Yes. It's this table, right?
Yes.
Yes. In this one, the objective of considering bioaccumulation is that it's relevant to notice that some compound might not be at risk for the single load, but during all these years, it can get higher concentrations in algae, daphnia, or in the fishes. So we thought that in the end, it would have an effect that was only main due to the bioaccumulation factor. Since if the compound is not bioaccumulated for any trophic level, then no risk is spotted. Therefore, we consider this as a critical parameter to be considered to determine if the substance has a risk for the ecosystems or not. It is true that other parameters would also be interesting to be considered here. For instance, I think it would have been very interesting to have a fifth column or maybe integrated to the toxicity the resistance genes, for example, for the antibiotics, which are not considered in the OPVT prioritization. And therefore, maybe more antibiotics would be of relevance. But the current model was to obtain the selection for our criteria.
Okay. In some way, you introduced already my next question. I mean, you make a huge introduction, but you don't mention it that maybe one of the hotspot problem is the antibiotic resistance gene bacteria that we have in the environment. And that I was curious why you, I mean, you don't also say like, we selected also because some of them are antibiotics. So
Yes. I agree. It would have been really interesting. Actually, 3 years ago, I went to a conference and they said that in 2060, more people will die for not having antibiotics than for cancer. That's one of the most problematic issues right now. So it's a really relevant topic. However, in my thesis, I focused on the analysis of pharmaceuticals, and therefore I did not consider the resistant genes. But I think it's something that would have been really interesting to integrate into the models and in the assessment factor calculations.
So, just I think last curiosity more regarding some treatments. So you had the possibility to study or to sampling from different treatment
Yes.
that are okay, classic and constructed wetland. It start to be often more used also because it's protect the environment, and after you have the flow up anaerobic bioreactor, etc. What do you think? What is still missing? And if it exists something that really can remove all what we need to remove, or at least for the fall of the criteria that you show, 4+2 and etc. If it exists some treatment, but especially, do you think that really we need to focus a lot of contaminants? And what about the microorganism? For your point of view, just as after your studies, I think you get an idea about all this system. So, what is necessary to focus on contaminant, especially maybe for the reuse? But maybe, what do you think is the most important to focus on disinfection for the reuse?
Yes, that's
What
true.
is your point of view on this topic, and which can be eventual treatment, or during your study, if you was more curious to deeper in one treatment than another, because it can have a more potential, not only taking in account of chemical removal, but maybe also microorganisms.
That's true. Yeah, it's something that I have not considered in my work, but it's true that in influent wastewater, apart from contaminants, there are several bacteria, and it's important to consider them. I remember from my doctoral stage in Ferrara that it was one matter of really relevance in the wastewater treatment plants, the amount of bacteria found in the fluent wastewater and in the Po River. In the case of the USV plus constructing wetland system, a tertiary system was also built, but it was disconnected from the wastewater. It was a NUV treatment, and the disinfection was performed there. It is true that in Catalonia it's only conventional activated sludge, but it's relevant to take into consideration that additionally to removing some of the most relevant pharmaceuticals, other threats must be also be considered as pathogens.
Yeah, also because I think it's compulsory. If you don't have tot number below such number of like Escherichia coli community, for sure you cannot use it as reuse, at least in agriculture.
That's true.
This is compulsory everywhere, also in North Africa countries. Otherwise, the people get sick.
Yes.
We bring back the cholera, let's say, okay? So this is compulsory. Okay, thank you. Again, congratulations for your work, and I will allow the president to...
Many thanks.
Molt bé, moltes gràcies per la presentació i felicitats per la feina feta. Una tesi no és qualsevol cosa, tu saps millor que ningú l'esforç que suposa i bueno, doncs, felicitar-te.
Gràcies.
Una tesi tampoc es pot fer sense algú que t'acompanyi, i en aquest cas has tingut dos directors que també mereixen la felicitació. Dit això, toca fer algun comentari, alguns ja els han fet, però jo te'ls faré en castellà per facilitar que ho pugui seguir. Bueno, en primer lugar, decirte que la memoria me ha gustado, especialmente el tema del risk assessment. Yo trabajé durante mucho tiempo con esto, por lo tanto, contabas con un lector predispuesto a favor. Esto siempre va bien. O sea que, por otro lado, también hay aspectos que me han gustado, como por ejemplo que tratases con detalle el tema de la legislación, que es importante porque al final la ciencia va por un lado, la legislación va por otro, pero la vida diaria, quien manda es la legislación. No nos gusta, pero es así. Por lo tanto, es un aspecto que a mí me ha gustado como lo has tocado. Y luego el apartado de perspectivas futuras, hay muchas sugerencias que también creo que son valiosas.
Gracias.
Dicho esto, vamos a las cuestiones, que para eso hemos venido aquí, como decía, pues esto se espera que hagamos. Primero, la base de datos.
Sí.
La base de datos está centrada en Cataluña, no en Mongolia exterior. Hombre, a mí me hubiera gustado ver un mapa con los ríos que has mirado. ¿Dónde estos 30 y pico papers?
Mayoritariamente es el TER. Sí.
Claro, esto es lo que se desprendía un poco del contexto y esto sesga un poco, cuando tú hablas de Cataluña,
es verdad.
Claro, hay ríos, si miras cómo está distribuida la población, los ríos que reciben más presión humana serían, pues, empezaríamos por Llobregat y Besós y de ahí para adelante. Entonces,
también hay alguno. En la database, pese a que la mayor parte viene del TER, el Llobregat y el Besós también están considerados.
Eso estaría bien enseñarlo de alguna manera, añadir una columna, no sé, explicando. Creo que sería... Otro tema que estaría bien para mejorar, digamos, la interpretación de la base de datos es, primero, cuando tú das un valor, sí, das un margen de error, pero podrías poner el número de veces que se ha medido, una N allí, esa media que se ha leído, ¿de cuántos puntos es?
Cierto, sí.
Claro, si son 2 puntos, pues a lo mejor la representatividad que tiene pues sería muy poca. También, digamos, máximo y mínimo, alguna medida de dispersión. Y esto te lo digo porque, no solo porque daría más calidad a la base de datos, sino porque para definir la occurrence que tú luego haces servir, hay algunas metodologías, por ejemplo, Norman, que utiliza o bien la extensivity, que es el número de veces que aparece un compuesto, o la intensidad, cómo sobrepasa. Entonces, son dos maneras de verlo que creo que se podría reflejar a base en la estadística.
Es verdad. En la primera base de datos sí que no lo integré, pero en la siguiente sí que tuve en cuenta la detección de frecuencia y el número de análisis. Pero en la primera aún no lo consideré.
Y si alguna vez nos pones un mapa de Cataluña, hombre, es casa nostra, tú, eso sí. Estaría bien saber cómo están las cosas. Bueno, esto por lo que se refiere a la base de datos. Vamos a otro tema que tiene que ver también con... Si pones, por favor, la diapositiva de los objetivos.
Sí. Esta. La puedo hacer más grande, ¿eh?
Bueno, yo la veo bien, no sé si los del fondo...
Aquí, sí.
Bueno,
así está mejor.
Si vamos al 1, 2, 3, 4, al quinto bullet,
Este.
Perform a risk-based prioritization of compounds in Catalonia and evaluate the risk in aquatic and soil ecosystems.
Sí.
Tú lo que has hecho se termina aquí. Esto falta. Y falta, te lo explico para entrar en facilitar la discusión. Aquí estás evaluando compuestos, aquí estás evaluando escenarios.
Sí.
En los escenarios los compuestos no están uno por uno, sino que están todos mezclados. Entonces,
Eso es verdad.
tienes que considerar las metodologías de riesgo conjunto. Hay metodologías de concentration addition y independent action que están muy descritas, que simplemente lo que tienes que hacer es sumar, por ejemplo, los HQs y el que un compuesto esté, o que todos los compuestos estén por debajo, el HQ por debajo de 1, si los sumas, muy posiblemente superas, no sé, hay que hacerlo, pero...
Sí, eso es verdad.
Es decir, hasta aquí, perfecto, yo te lo compro tal como lo has hecho, pero sin esto yo necesito que des un paso más y consideres la mezcla. Esto simplemente es sencillo de hacer, pero
Podría poner un asterisco con
bueno,
el
queda
modelo,
pendiente si
pero
te puedes hacer...
Sí. Sí, es relevante. De hecho, en el Further Studies, en este apartado, digo que siempre el riesgo se ha medido de forma individual, pero no tenemos en consideración el efecto cóctel, las sinergias y cómo todo el conjunto puede afectar. Eso es
Los
verdad.
escenarios siempre están conjuntos.
Sí.
Entonces, y no solo farmacéuticos, además.
Sí, otros contaminantes.
Pero bueno,
EDCs.
ya me centro en lo que tú has escogido, farmacéuticos.
Gracias.
Sería importante, sobre todo si quieres añadir esto, si quieres.
Sí.
Y bueno, ya ves que tenía pocas cosas, algunas ya se han comentado. En las perspectivas futuras también, sí, bueno, ya se ha hablado de temas como el target, suspect y non-target, también de analizar distintas matrices, como pueden ser sedimentos de ríos, sludge de depuradoras, bioacumulación en organismos vivos, todo eso más o menos ya se ha comentado, pero hoy me he enterado, hablando con Sara, que estás en la industria farmacéutica.
Sí.
Entonces, quizás sería interesante intentar cruzar, por ejemplo, los datos de occurrence que vienen de monitoring con los de ventas de compuestos.
Sí, es decir, esto va más en
Son
la
dos
línea de lo
formas.
que comentaba Mary. Sí, creo que sería bastante relevante. De hecho, hay un artículo, creo que lo comentas en el artículo de 2015, que analiza ríos, que es importante determinar cuando un compuesto qué contrapartida environmental tiene. Es decir, si existe una alternativa para ese fármaco que también puede solucionar nuestro problema, pero no implica luego un riesgo ambiental, se debería ir por este lado. Este debate actualmente se tiene con el acetromicina y el diclofenaco. Entonces, sí que creo que sería muy interesante llevarlo a la discusión y llevarlo también integrado en el sistema de riesgos, ya considerando lo que comentabas del efecto cóctel.
Y un poco también en la relación esta con la industria farmacéutica, claro, hay compuestos o hay, digamos, los tratamientos médicos están en evolución. Entonces,
Sí.
por ejemplo, si coges para bajar el colesterol de hace 15 años, pues te encontrarás gen fibrocil, ácido clorfíbrico.
Cierto.
Ahora te encontrarás las estatinas.
Sí.
Claro, a lo mejor hay menos experiencia, entonces estaría bien ir adecuando. Indirectamente ya lo estás haciendo, pero hacerlo de una forma más explícita y quizá ahí sería una buena forma de cooperar con...
Sí, aquí nos ayudaría mucho incorporarlo de las prescriptions para poder ver
Claro.
qué podemos esperar, pero también el non-target, que comentaba Mary, porque al tener ratios de metabolización distintos, quizás es un metabolito el que tenemos que tener en cuenta para una simvastatina. Pero sí, sería muy interesante combinar estos dos approaches.
Pues, por mi parte, esto sería todo. Felicitarte de nuevo.
Muchas gracias.
Creo que ahora nos toca irnos a deliberar. Pues muchas gracias a todos. després d'una curta discussió i uns quants papers que hem hagut d'emplenar per la burocràcia que tenim a darrere, hem decidit donar la màxima qualificació, que és excel·lent.
Hay que ver, sí, claro. Eso es la millor part, no? Sí. No sabes dónde mirar.